Okay, part 2 or type 2. Sorry the first video was so long, but you know me, I like to explain stuff. Over explain sometimes, yeah? Type 2. Type 2 is way more critical for understanding what's going to happen, not next week, but the week after that. So this is critically important. Yeah? Critical. So the previous type of problem, we told you the length of the sides. This time, we're going to tell you the length of the hypotenuse. Like that. And you're going to have to find the length of these two sides. So, I'm going to call this X, I'm going to call this X. I am allowed to call them the same thing because they are the same length. So you can use the same variable. Yeah? That makes sense? Then now it's Pythagorean theorem. X squared plus X squared equals 8 squared. X squared plus X squared equals 8 squared. And then combine like terms. 1x squared plus another x squared is equal to 2 of them. And voila. I don't know why I didn't just write 64 to begin with right there. I should have, but that's okay. It just adds an extra step. Voila. And now I'm going to solve for x, because that's what you do with the equations. Yeah? Divide by 2. Divide by 2. Yes, you have to do it in that order. These cancel. X squared equals 32. And now, square root both sides. Square root. So squaring and square rooting cancel. You are left with x equals the square root of 32. And square root of 32 is equal to, remember how I said in the previous video, all 45, 90s will have a radical 2 in it somewhere? Well, that's also going to be true here. Let's see. 32 is equal to blank times blank. But, because I didn't lie to you in the previous videos, you know that one of these is going to be a 2. Because I said always 45, 90s will have a radical 2 in it somewhere. So now you just go like this. 2 times what is 32? The answer is 16. Yeah? And then the square root of 16 is 4. So you get 4 times the square root of 2, which is 4 radical 2. Yeah? So, both of these sides are equal to that, which is like 5.7 or something like that. So these are 5.7, these are 5.7, and this is 8. Bigger. One of my pet peeves is when students think, oh, this is the same as this, and this is the same as this. No, it's not. No, it's not. That would be an equilateral triangle, number 1. Number 2, your eyeballs tell you this is longer than those. Come on now. Shoo. Next example. Actually, let me replace these x's with an actual number. Bam and bam. And then we're going to do a couple more, and then you will see a pattern. You always want to do at least 3 examples before you jump to a conclusion. Like, for example, first person to walk into a room, ugly. Second person, ugly. You can't assume the third person gonna be ugly. But if the third person comes in and they're ugly, then yeah, we're gonna assume that fourth and fifth and sixth is gonna be ugly too. That's called inductive reasoning, by the way, that you're supposed to see 3 examples before you jump to conclusions, even though clearly my analogy was not a good example. Anyways, but mathematically True. You want to see 3 before you jump to conclusion. So, next example. What if I tell you the length of the hypotenuse this time is 10? What is the length of those two sides? Again, I'm going to call them x. Voila, voila. And I'm going to set up the simple equation, x squared plus x squared equals 10 squared. X squared plus x squared equals 10 squared. And 1x squared plus 1x squared is 2x squared. That's 100. This time, saved you a step. And divide by 2. Divide by 2. Those cancel. Actually, like I've said many times in class, probably hundreds of times, there's no such thing as canceling. It actually equals 1, so it's 1x squared. You just don't write the 1. No need to write the 1. 100 divided by 2 is 50. Then you square root both sides. Voila. Voila. Those cancel. And you get x equals, square root of 50. I don't know what that is. I go to do over here, but I will tell you. Break it into 2 pieces. One of those pieces is going to be radical 2. So 2 times what equals 50? The answer is clearly 25. And the square root of 25 is 5. Voila. So 5 times the square root of 2 is x. There you go. How big is that for real? Probably like 7 point something, 7.8, 7.7. I have no idea. Ooh, let me check. Why do I want to check? Just because A, I love math. B, I want to know. Because I have no idea. If someone say, hey, me, go draw, or go cut a board 5 radical 2 feet long. I don't know what you're talking about, man. But I know how 7.1 feet, I know my brain can conceptualize how long that is. That, no. No bueno. Bueno. Caleb, no decimals. No decimals. We now know that this is 5 radical 2. This is also 5 radical 2. How big is that in real numbers? 7.07 or 7.1-ish. So this is like 7.1-ish millimeters. That's like 7.1-ish millimeters. This is 10 millimeters. Bigger. The hypotenuse is bigger. One more example. Oh, that does not look right at all. That's better. Okay, and it's a right triangle. I probably should have did some sort of marking to tell you that it's a 45-45. Voila. There. Now, good geometry. That's good geometry skills. This time, let's go with the hypotenuse of 6. This is x, this is x. I'm going to go faster now because you've seen it a couple times. X squared, and I'm also getting close to the 10-minute mark. X squared plus x squared equals 6 squared. That's 2x squared, 36. Divide by 2. Not even going to do that in green. X squared equals 18. 18 is 9 times 2. Square root of 9 is 3. So you get x equals 3 radical 2. Voila. 3 radical 2. So now let's look at the pattern. If we tell you the hypotenuse is a certain integer, so you got 8, 4 radical 2. 10, 5 radical 2. 6, 3 radical 2. So, in general, and I probably should have said this in video 1, we don't need to see any work. No work, people. We just want you to quickly, very quickly, understand the pattern. So, if I tell you this is 20, you should understand that the length of this is exactly half of this times the square root of 2. Yeah? That's what we want you to do on the actual assignment. We don't need to see this work. If you want to do that, go right ahead. It's good for you, yeah, but not necessary. So Akira, that probably made you super happy and got to show no work. So that's type 1. Let me go back to type, or sorry, that's type 2. Let me go back to type 1. Of these, again, we don't need to see any work. If we give you a 45 degree right triangle, and we tell you that this side is 16, that side is also 16, then the hypotenuse is 16 times radical 2, bigger. Yeah, no need to show work. This is optional. If you do show work, don't even think about showing no decimals. No decimals. Alright, good luck. There are a lot of problems, but actually there's not a lot of problems, only like 10 problems, but we want you to go fast. Yeah?